Welcome to day 2 of the Intuitive Limits course. Today we're going to talk about the basic rules for dealing with limits, and we're going to solve some basic problems. So to begin with, we need to know some basic limits. And the first limit we're going to solve is the limit of the function f of x equals to x. This is almost the most basic function you can think of. So the graph of this function is this straight line here. And well, we're going to fix a value a in the x-axis, and we want to calculate this limit. Well, here I already showed the answer, because it is really intuitive, because we're taking the limit as x approaches a of x, and here we already are saying that x approaches a, so x should approach a also. That's just the intuitive idea of limits that we talk about in day 1. So this is the first limit that we should know. The limit of x as x approaches a is a. Another basic limit is the limit of a constant. Here we have the function that equals a constant b at every point. If we take the limit of this function as x approaches any value a, the limit will be the same constant. This is pretty intuitive also. Now let's talk about the limits of a sum. How we calculate the limit of the sum of two or more functions. For that, we're going to consider two functions, f of x equals to x and g of x equals 5. And we want to calculate the limit of the sum of these two functions. What is the limit of f of x plus g of x as x approaches a? That is, we want to calculate the limit of x plus, well, here it should be 5, not 6, well, we'll stay with the 6 here. What is the limit of x plus 6 here when x approaches a? And the answer is that to calculate the limit of a sum, you calculate the limit of each of the terms and then sum the limits. That is, the limit of the sum is the sum of the limits. And here we already know that the limit of x when x approaches a is a, and the limit of this constant is a constant. So we can generalize this to more than two functions. When you have two or more functions and you take the sum of these functions, if you want to calculate the limit of that sum, you just sum the limit of each of the individual functions like this. Now let's talk about the limit of a product. This is very similar to the limit of a sum. Now we're going to consider these functions. This function f of x equals 3x squared, and we want to calculate the limit of this function as x approaches a. In this case, well, this is very similar to the limit of a sum. The limit of a product is the product of the limits of each of the individual functions. Because we can think of this function as the product of two functions, the function constant equal to 3 and the function x squared. So we calculate this limit as the product of these two limits, and the limit of 3 is 3, and the limit of x squared as x approaches a is a squared. So this is easy. And another property that we can deduce from this limit is that when you have a constant multiplying another function, you can take the constant out of the limit sign. If you do that here, you'll get the same result. Now let's talk about the limit of a quotient, and for that we're going to try to solve this example here. Here we have the limit as x approaches 1 of this function that is the quotient between two linear functions. And here, to calculate this limit, you simply take the quotient between these two limits. That is, you take the limit of the numerator and the limit of the denominator, like this. And here we calculate the limit that is here in the numerator. Here we have that 6x plus 4 will approach 6 times 1 plus 4, and 3x minus 1 will approach 3 times 1 minus 1, and that will be 10 over 2, that's 5. That's the answer. So now we're ready to solve some examples, some simple examples. Here we have the limit as x approaches 0 of this product. And to calculate the limit of our product, we take the product of each of the limit of each of the factors, like this. Here we have the limit of x minus 2, and x approaches 0, so this will be minus 2, 0 minus 2, and here we have x plus 3, but x approaches 0, so this is 0 plus 3. So we get that this equals minus 6. This was easy. Let's solve another example. Here we have the limit as x approaches minus 2 of this quotient here. So here we take the limit of the numerator. We have the limit of 2 minus x, and here below we have the limit of x plus 1. 2 minus x will approach 2 minus 2, and here below we have minus 2 plus 1. So here we get minus times minus as plus. We get minus 4, and that's the answer. So you can see that solving limits using these simple properties is very easy. It is just like solving simple algebra problems. So that's all for now. Thank you for watching, and see you next time.